Hello everybody! In this video I'm going to show you how to create isometric tile maps using Unity 2019. And first of all, let me show you the end results. This is the scene from my latest game. You can find the link under the video. In this game there are those balls that I call them moons that are following the path. The path is the dotted tiles that you can see here. That's exactly what we are going to build programmatically. So yeah, let's just get started. Here you can see our newly created 2D project open. Yeah, it was created in 2D mode since we are building the 2D game. I have already pre-uploaded the tiles here, the same tiles that I used for my game. The important note here is the import setting that you should use for the tiles. As you can see here, they're all 1096 pixel per unit. This is because the width of this tile is 1096. I will post another link to the Unity blog where it's all very nicely described, but long story short, you should use the same width for this tile to occupy exactly 1 unit on the screen. You will see it later if it's not clear now. So let's start with creating the empty game object. We'll call it the game zone. This is the object we will be using to place our board where we will paint our tiles. Next step, you should have this tile palette open. If it's not here, go to Window, 2D, Tile Palette, and that will open this window here. And let's create a new palette. Let's call it board. And the grid size is isometric. The same technique can be applied to any of those. Let's create, let's save. Nice, it's saved here. Now let's create the tile map itself. Let's put it under the game zone. Select the isometric type, layout, and the cell size should be a little bit different because it's isometric, so it should look isometric. Yeah, it's called 2.5D. Good. Let's go back to tile palette and drag and drop our tiles. Save. 1, 2, and 3. Very good. So let's start with the board. We will create a board 11 by 11. We can use this fill box brush. Last thing that we should do, we should compress the bounds. This is the expensive operation, that's why it's not done automatically, and by default Unity creates a tile map with unlimited bounds, but since we know that the bounds will always stay like this, 11 by 11, we can compress it here. Yeah, you will see that it is this big. For some reason I had to restart the Unity in order for this to be displayed, but yeah, happens sometimes. So this is the exact size of our tile map. With this board created, we can go now to the next stage, and we will create the level data to describe the setup of each level. Now let's create the description of a level. We will store it in the JSON file, and then later we will read it in the runtime from the script. First of all, let's create the folder. Let's go to files. Let's create another folder, resources. That's how Unity knows how to load the file from the resources. Then let's create another file here. Let's call it levels JSON. Very good. And let's open it in Reader. You can use Microsoft Visual Studio, but I just prefer Reader. This is the file. Here you can see that it's an array of levels. Each level has a identifier, like level 1, level 2, and the path. The path is the path from point A to point B. And this is exactly what we are going to build programmatically. This is how basically we describe our levels. Because in the real game this is way more complex, but for the tutorial purpose I kept it super simple. Now we have the file and we should read the file somehow, right? So for this purpose let's create a first C# script. Let's call it the levels data. Yeah, this is basically the description of our data, so we don't need it to be mono behavior, but we will serialize it. So we and the serializable field. Yeah. So our data looks like that. So the array. That's why we will create the array of what, you might ask, right? The array of the level data. So let's create another class inside level data, and this is the level data. So there is a number and a path. Number is the int, public int number, and the path is the another array. It's public and path. And it's all is the array of level data. Let's call it levels. Get extra imports here. Yeah, this is the internal class that is also serializable, so we need to put the serializable annotation on top as well. Okay, now we have the file and the data that describes this file. The next logical step is to read this file into the data somehow. For this, first of all, let's create another C# script. Let's call it the game zone. This is kind of the master of all. We will use it as the script that will load the path here programmatically. And let's also create another script that we will call levels data loader. Very good. Game zone, let's open both, and let's start with the levels data loader. First of all, also attach it to the game zone. We will access one from another. We don't need the update actually, and we don't need start as well. But what we need is the one method that will return us the dictionary of the levels. Level data. Let's call it get let's call it read levels data. Very good. This method will load the files from the resources. For this we use the resources load method, which accepts multiple parameters. This time we will use the last one with path and the type. So the path is just the name of the file, basically, which is levels, and the type is the text asset, because it's a text file. And we should also cast it to text file. Yes. And this is the file. That's how we access the file. Next thing is to load the data, and to load the data we will use the JSON utility. And the from JSON method with the levels data type. This method needs a string, and the string we will take from the file text. Now we have an access to the levels data. It's possible, yeah, let's have a, this is not null. It's nice. So now we have the levels data, and we want to actually do the other way around. If it's null, let's just throw the application, let's say exception, application exception. The levels file is not accessible. Of course, it's a typo. Yeah, now it's better. It's really hard word to spell, I don't know. But now we will do it a little bit smarter, because this method returns the object of this type, and that means that we have access to the levels already. So we can just iterate over levels and convert it to dictionary using link. As the first as the key, we will use the number. Very easy, just level number, and as the value we will use level itself. And that's all we want to return. Yeah. So basically this is the dictionary that we will use to map the number to its data. Now let's access this data loader from the game zone. Private data loader and get component levels data loader. We don't need to update here, and let's just do the read levels data, and for instance let's outprint the size of it. So we know that we did everything right, and if we did everything right, the size should be 3. 1, 2, 3. It's all done, it's all saved. Let's go back to the Unity and let's hit play. 3. Very good. That means that we just created a code to read the dynamic data per level here. Cool. Now let's move on. What now we want to do, so we did our basic setup, basic preparation. Now what we need to do, we need to somehow access the tiles. Pretty much those tiles. No, we don't need this, only start, stop and horizontal ones. We need to access them somehow from the script. For this we will use the same technique with the resource folder. So let's create the resources folder in the tiles. Let's move this horizontal and start and stop into that. And now we'll be able to access them from the script. Okay, so let's access them from the script. This, let's create the new tiles resource loader. This will be the handy utility script that will just access the tiles from the resources. So since it's a utility script, we can make it static. Let's create a couple of methods to access actually the tiles. Static tile maps, get tile by name, string name. Here, what we want to do, we want to obtain the tile, right? So we need to use the again resource load method with the path. The path will be the name of the file, and the type will be tile. And we need to again cast it to tile. So since we have two tiles we want to load, we can just have the constant string on the top. The first one is horizontal with the name that is horizontal, lowercase, horizontal, and the same one for start stop. This is the start stop, this underscore, start stop. And now let's create the public static methods, which will also return the, say, first horizontal tile, and let's reuse this nice private utility method that we created in the beginning. Horizontal and start stop. Start stop. Very good. The next step is to use it. Let's use it on the start here in our game zone. We don't really need this loader to be an instance variable because we just need the data from this loader. So let's just create the dictionary instead here. Let's call it level data, and let's load it from the loader down here directly in the startup. Good. So the last step, let's set up the tiles. To set up the tiles, let's create another private void method here. Let's call it setup tiles. First of all, let's access the tile map. Without the tile map, we can't change it, right? So to access the tile map, we will use that component and children. We have only one tile map, so we don't need to use the components. Component is enough. So this is our tile map. Yeah, this is the tile map that we want to fill with the new tiles. So now all the tiles are this simple, clean, oh, just purple in this case. But we want to change the tiles and the runtime with this horizontal and start and stop. So in order to do this, we need to access all the positions of the tile, get these positions, and change the certain tiles at certain positions. For this, we will use the following technique. In order to access the all position of the tile map, there is a cell bounds that return the boundaries of the tile map, and the handy method hold position within that basically returns all the position of each and every tile in the tile map. And we want to iterate over this list of entries, which is list of vector free int, because each tile is identified by the coordinate, and we want to store it somewhere. Let's create another list for that. Let's call it the local tiles positions. It will be the list of vector 3 int position. Spelling errors are hard. And we want to add the new local position, which is vector 3 int local position equals new of these, let's just call it pos for simplicity, position x, position y, and position z. And this is the position that we want to store in the local tiles position list. Just add it there. So this list holds the local positions of each and every tile in this tile map. And the trick is that those positions are ordered. So if you look at the tile map here, the first position will be here. So there's 0, 1, 2, 3. This is an index of the element in the array, the list, sorry, that we created here. It will be from 0 to up to 11 multiplied by 11, which is 121, but since it starts with 0, then it will end at 120. So the first will be 0 and the last one 120. And as you might have guessed already, we will use those indexes as the positions in the path. So suppose this 22 and this 32 will represent the index in this array. And then if you look at this tile map again, you can say that, okay, 22 will be somewhere here and 32 will be somewhere here. And then you can have a picture with all these tiles numbered somehow. I can show you actually mine that I used during the development of my game. This one. Yeah, I know it looks ugly, but that's what I used. From 0 to 120. And then you can describe your levels using this technique here. Basically the last step that's left, let's set up the path. Yeah. This method will need the tile map and the position. So position is this type, positions, and the tile map is tile map. So first thing that we need to do is to, of course, provide the positions to the method. Tilemap. And now we want to access the level data, and for this we need to keep track of the current level. In the real game, that would be some kind of the button you press, and then the level number is saved somewhere. But for simplicity purpose, let's just have a public int level variable that will point to 1 by default, but then we can play in Unity and see how the setup of the board will change depending on the level. So with this level data, we can access the level data of the basically given level. And in order to set up path, we need a path in line 1 and 2 another And next thing, we want to load the horizontal tile, right? For this, we will use this handy static helper class that we created and the methods. So this is our horizontal tile that we will put on the tile map. This path variable describes the first and the last point of the path. Basically where the path starts and where the path ends. Yeah, let's just illustrate it with the variables, then it will be probably even easier to comprehend. So it will use path first link and then the last, not the cast but last. Let's iterate over the positions starting from the first position of the path till the last position, right? But the getRange method has two parameters. The first one is the index from which we start, and the second one is the count. And the count in this case we can calculate using math absolute number. We can just subtract first and last, then we will have the exact position of the tiles that we want to change on our tile map. And in order to change it, you can just use the simple method set tile, and let's set the horizontal tile, but first we should provide the position, of course. Yep. So this is done. So let's now switch back to Unity and see how it works. And as you can see, we have the tiles here created programmatically. Yeah, as you can see, the last tile is missing. Yeah, let's fix it straight ahead. We have this start-stop tile, which indicates the start and stop of the path, so let's just use it for this. Let's first access it and simply set the tile for this local, it's called positions, yeah, of the first tile, and the tile is start-stop, and do the same with the last position. Switch back to Unity and let's see how it works. Excellent. The first tile is created and the last tile is created. As you can see, everything works fine. The path is created purely programmatically. Let's now choose another level to see that it all works for other level as well. See, the other level is created here, and since we have 3 levels, let's check the third as well, and the third path is here. Very good. Thank you for watching, and see you next time.